as you can see, I got the second speaker put together, and that went quite a bit smoother. I didn't make any mistakes, or major ones anyway, on this one, and that helped. And also I had the experience of putting the first one together and all the stuff that went into that to rely upon for the second one. It's always the case. You know, the second one will almost always go quicker than the first one. And I'm glad it did. Right now it's sitting outside in the sun, although it's pretty early in the morning yet. I'm going to leave it out for, I'm going to shoot for around 4 days. And this is not in direct sun. This is kind of sheltered. It's underneath a porch roof, so that it's getting sunlight, but it's not direct, okay? And that's how long I put the first one out for, to get a suntan, to darken that cherry. And it turned out really well. So kind of in between doing the first one and the second one and waiting for things to dry, I started making these. These are the horn flares for the tweeters. You can notice that when I cut out the hole for the tweeter, it seemed really big, right? And that's because this thing goes inside there. Now this is black walnut. I designed the shape in SketchUp. It's not really based on any math or anything. It's just, you know, what looks right. And then I cut it out on the CNC. Of course, I did a couple of samples first until I got it right. And so that was a little bit of a learning experience on the CNC as well, making this shape the way I designed it. So these are still on hand because I haven't put them in the baffle yet. What I want to do is, well, what I'm going to show you in this video is actually testing what this does to the tweeter. Because, okay, there are a couple of reasons. Well, one primary reason why I'm using this and not just putting the tweeter in the front. Because I think from my testing in the basement, it would actually work better if I just mounted it flush on the front. But by doing this, I get some time alignment correction. Even though I have that ability in DSP, I'd still rather do it, say, physically if I can, like move the tweeter back. Also, the baffle itself, the speaker itself, tilts back about 2 degrees. Now, what this does is it makes the tweeter more efficient, except it only works in a certain range. And I want to see how this particular shape here works for the tweeter that I have. So I pulled one out of one of the prototypes I have in the basement, and I made a baffle from MDF. And the first thing I tried was surface mounting, because I wanted to show, like while I was at it, I thought I would show what diffraction is as well, because that's another thing that people think is a big issue. And I wanted to kind of put, a fine point on that as well. While I'm doing it, like I'm doing it, I might as well do it. So I surface mounted the tweeter and I ran the first test. And you can see the response. I smoothed it to 1/24th. And I also gated the response, which also cuts out the reflections. And you can see that it's a little bit wavy up on the top. But what I did next is something you probably haven't seen before. I actually took a piece of music. In this case, it's a piece of violin music. And I recorded that with the measurement mic at the same position. And, to get an idea what that sounds like. And I'm going to do that for every sample. So you'll be able to compare how the thing actually sounds as accurately as I can do it here. All right, I'm recording, the measurement mic is about 24 inches away from the tweeter. So it's getting good response. It's nice and close. And, the measurement mic itself is very accurate. So the recording should be a good representation of what you would hear. Now it's only mono, I know, but still, you'll be able to hear that, and then you'll be able to compare it to the ones that come after. So for the next one, I made the tweeter flush. I routed a recess for it to fit in, so it's nice and flush on the surface, and I ran the sweep again. And as you can see that it's different. It's actually flatter up high. Those waves, those wrinkles have flattened out. So by every objective standard, people would think that that's better. Flatter response is better, right? Now, the question is, do you hear that? Lots of people say that you do. Lots of other people say you don't. I'm one of the people that say you don't hear that, especially up higher like that. So I, once again, did the recording, and that's what you're listening to now. So another way to deal with diffraction is to take the square edges on your speaker and round them over, okay? Everybody knows that. That's into speaker building and knows anything about speakers, you know, technical about speakers, knows that if you round over the corners, it's gonna make a big improvement to the amount of diffraction. So I did that. On our test baffle, I set up my router table, rounded over the corner, put the tweeter back in, put it back on my bandsaw where I was testing it. Nothing's changed. Everything's in exactly the same place. The microphone doesn't move or anything get unhooked or anything. And I ran the sweep again, and here you can see the results. So if there's a difference there, it's very slight and probably not worth the time it took to do it, unless this is the look you're going for. You want to have the rounded corners strictly for, you know, appearance. So the next thing that I did was I actually put the horn in. And to do that, I had to cut out the hole big enough to fit the horn in. And because I routed out to the size of the tweeter, that recess, I had a little bit of a margin around there that I had to cover up. And I did that with tape just to cover that gap so that we wouldn't be getting any diffraction. And I put it back on the thing and I ran the sweep again. And because the horn does raise the efficiency of the tweeter, I actually ran into a clipping problem, as in the volume was getting too high. So I let that measurement go through just to look at it, okay? And you can see that it's a good 6, maybe 8 decibels higher. And that's, you know, that's what a horn gives you. But you can also see that it turns down up in the higher frequency range, which is maybe a problem for some people, but for an older guy like me, I'm not hearing anything up there anyway. So it doesn't matter what it's doing. It could drop like a stone up there, and that wouldn't matter. But you know, that's something that happens with horns. You lose that little bit. I don't know if it's a throat cancellation or something. Maybe a phase plug. Maybe I could experiment with a phase plug after I get these installed, just something blue tacked in place just to, you know, run some measurements and see if that makes a difference. But in the meantime, it's not an issue for me. What, you know, the big thing that this does is it lifts the response in a lower range, usually in the lower range of the lower operating range of the thing that you're using it with, like a tweeter. And what that allows you to do is to actually flatten that out to match the other drivers, but it gives you more coverage. It'll allow you to cross that tweeter down lower, so it covers more, you know, of the frequency range. So I didn't make a recording on that one. I ran the sweep again after turning the amplifier down enough so that it wouldn't be clipping anymore, and that's what you're seeing here. And then I did make a recording of that. Next, I did an off-axis recording. I moved the mic to about 30 degrees off of, you know, before the microphone was pointing directly at the tweeter. Now I moved it over 30 degrees and I ran the sweep again. Once again, I had a problem with clipping, even though the amplifier was still turned down. I let the swing go. I didn't make a further recording with the amplifier turned down even lower. And we can see the response in relationship to that second horn measurement here. And I also recorded that violin music so you can hear it here. Now, I'm sure a lot of guys will make a big fuss about how the horn is flared, the actual geometry. All I did was I drew it up in SketchUp, and the main point of a horn is that it gets bigger as it gets further to the, away from the thing, so that it interfaces with the surrounding air, more efficiently. The tweeter will. It has less air in front of it to push against, therefore it's more of a load for it, and it's more effective. So the horn flare might make a difference, if it was shaped differently, but I don't think it would be significant, especially not for something this shallow and this sized. So yeah, the next thing to do is finish letting my speaker number 2 get a suntan, and then I can actually get these glued in, but I want to get a finish first. Actually, I left this part out. I finished, well, partly, speaker number 1. I gave it about 4 days sitting out in the sun to darken, and it looked really good, but then it really looked good after I sprayed on the first very thin coats of oil-based polyurethane. I wanted something, I was like, I'm a big water-based guy, but I thought that, I wouldn't be getting the full punch if I didn't use oil-based on this. And that's one thing, the big benefit that oil-based has is that it will really bring out those, color variations in the wood.